All right, today is going to be lesson 16. Here we're slopes of a line, and this is going to be pretty much exactly tied to a rate of change, but now we're going to call it the slope. And we're going to talk about different ways that you can find a slope on a graph, different ways you can draw the line on a graph if you know the slope and you know some points. Okay, so we're going to kind of just dive deeper into everything that we did in 6.1, looking at rate of change. So the big idea today, a line has a constant slope equal to the rate of change between any two of its points. All right, so the definition of a slope is the constant rate of change. So we're measuring the rate of change of a line on a graph, positives going up, negatives going down, 0 if it's straight across and there's no change. And if there was a vertical line going straight up and down, that slope is undefined because we can't measure how fast it's decreasing because it's going straight up and straight down. It's undefined. And we'll talk about what that looks like in terms of the mathematics. So the slope of a given line is going to go back to that same formula we were using. In 6.1 for rate of change. So this is the slope formula. So what this actually is talking about is the change in the y and the change in the x. So that little triangle means change. You're going to see that a lot throughout your high school math career. So you want to get used to seeing that triangle. It means the change. So how much did the y value change? How much did the x value change? And when we set that up in this ratio, that's going to give us the slope, which is a measurement of how fast it's increasing or how fast it's decreasing. Okay, so in this specific case, it doesn't matter which one you call your point 1 and point 2. We talked about that last week. So if we're going to take this one, we can call this our x1 and our y1. And we're going to call this our x2 and our y2. Now, you could have done it the other way around again. It doesn't matter. So on the top, we're going to subtract y2, which is 10. Remember, this is x and y, minus y1. So y1 is 7. And then on the bottom, we're going to have x2, which is 15. And we're going to minus x1, which is negative 3. So it's going to be minus a negative, which we know goes plus plus. So 10 minus 7 is 3. 15 minus negative 3 goes plus plus. So it's really 15 plus 3. This is 18. Just like any ratio or fraction, you want to simplify it if you can. So 3 over 18, you can divide those by 3 for a final answer of 1/6. Notice it's positive. Okay, that means this line is increasing and going up from left to right. 1/6 is a small number, so it's not going up at a very steep angle. It's going up gradually, but at a constant rate of 1 to 6 in terms of the y compared to the x. So it's going up 1 box over 6, up 1 box over 6. So you think about the change in y. Y is your vertical axis. So that's how much it's going up or down. And x is your horizontal axis. So for every 1 unit that it goes up, it's going over 6. So this is your up and down, and this is your side to side. So for every 1 unit that it's going up, it's also going over 6. Up 1 over 6, up 1 over 6. That's what the slope is. Okay, so example number 2. Do these points, there's 3 of them, all lie on the same line? If you put them on a graph, could you draw a line through all 3 points? Do they all lie on the same line? Explain. So the way that you're going to figure that out, if they're on the same line, they have to have the same slope. So the slope from this point to this point would have to be the same slope as this point to this point. If we drop back up here, if there was another point here somewhere in the middle and we wanted to say or prove how they're all on the same line, they're all going to have the same slope. If we measured from here to this first point, that slope is going to be the same as from this point to this point. It's always increasing by the same amount. If it wasn't, this wouldn't be a straight line. If all of a sudden it increased more and went up like this, well, now your line's not straight anymore. So if it's a straight line, it's going to have a constant rate of change, and so they're going to have the same slope. So all we need to do here is test the slope from point 1 to point 2, test the slope from point 2 to point 3, and if they're the same, then we know that they're all on the same line, so we don't have to put them on a graph. Now, you could put them on a graph, But in this case, we're looking at it in terms of actually finding the slope. So we're going to start with the negative 2, 5 and 2, 3, going back to our same formula. So again, it doesn't matter which one you call which. I'm just going to call this one y2. So it's going to say 3 minus 5, the y minus y. And since I went from here to here, I got to go from here to here. So 2 minus negative 2. All right, so I'm going to get a negative on top. 3 minus 5 is negative 2. And this is going to go plus plus, so this is positive 4. So I have a negative on top, positive on the bottom. That means my slope in general is negative. Okay, so if both of them are negative, they would cancel and be positive. But since this is just one negative and one positive, a negative divided by a positive is a negative. So this is going to be a negative slope, and we can simplify this to 1/2. Okay, so the slope between these 2 points is negative 1/2. So picture what that would look like on a graph. It's going down, and it's going down 1 over 2, down 1 over 2. All right, so now we're going to test it from 2, 3 to negative 10, 9. What's the slope between these two lines? Okay, so we're going to do 9 minus 3 for my y's, and we're going to do negative 10 minus 2 for our x's. So I get 6 on top. Negative 10 minus 2 is negative 12. So back to what I was just talking about, I have a positive and a negative. Positive divided by negative is a negative, and I'm going to go ahead and just put that negative out front. It makes the whole fraction, the whole ratio, the whole slope negative. But again, if I had two negatives, one on the top, one on the bottom, those would cancel each other because a negative divided by negative is a positive. All right, so it's negative, and 6 over 12 also simplifies to negative 1/2. So to answer the question, do these points all lie on the same line? I would say yes, and explain, because their slopes are the same. All right, so more practice with that slope formula. Testing, is the slope from this point to this point the same as from this point to this point? And if it is, they're all going to lie on the same line. Okay, example number 3. Find the slope of the line without using the slope formula. So without going ahead and plugging in all your x1s and x2s and using this formula, can we come over here and figure out what the slope is without that? So again, slope is your change in your y and your change in your x. And mathematically, we can figure it out by subtracting. But if we already have the graph, we can go ahead and we can figure out what the change in the y is and what the change in the x is. So we're looking at line P first of all. So that's this one. And so change in y is the up and down. So you want to pick any 2 points that are on that line, and you're going to kind of measure the distance here. So as I go from this point, I'm going to go from the 2 points that were already given to me. All right, and if you weren't given points on that line, you have to find a spot that it hits right on the corner of a box. You can't measure to, let's say, from this one to here or to here. Well, actually, you could to here. If you notice, this is going to hit right in the corner of that box. Okay, so that would be going down 2. Okay, so what you can't measure to is something that's kind of floating in the middle. So if you weren't given these 2 points, find a spot that sits exactly on a point on a corner. So we're going to use these 2 just for this exercise, but I'll show you how you could have used this as well. So measuring from here to here, what's the change in the y, which is the up and down? So it's going down 1, 2, 3, 4, 5, 6. It's going down 6. So first of all, that's a negative because it's going down 6. And what about my change in x? So my left to right, from this point to this point, how much change has there been from left to right? So it's going over 1, 2, 3. So you're going from right here to right here. So I have this point and this point. How far has it gone from left to right? It's gone over 1, 2, 3. So the change in x is there. And if I simplify this, negative 6 divided by negative 3, that'd be negative 2 over 1, and you can just leave it as negative 2. Now, let's say you had seen this point right here, going back to this. You'd seen that point. That's right on the corner of that box, so I could use that. So what would be my change in y here? Down 2, so negative 2. And what was my change in x left to right? 1. And this would also simplify to negative 2. So you don't have to use the points that are given to you. Any points on the line are going to work. But again, those points have to be right on the corner of a box. They can't be floating in the middle. You can't just call it a half because you think it's right in the middle. Okay, there's no estimating on those points. All right, now we're going to confirm that answer by using the slope formula. So we're going to make sure that we're going to get the same answer if we use this. Now, in order to do that, we got to actually have these points right here. So this point, let's call this x1 and y1. So the x is negative 1, and the y value is 4. This one, we're going to call this our x2 and our y2. And it's 2 over 2 down to negative 2. So if we're plugging that into this formula, you're going to have negative 2 minus 4 for your y's. And for your x's, you're going to have 2 minus negative 1. So 2 minus 4 is negative 6. 2 minus negative 1, that goes plus plus. That's 3. And so that's going to simplify to a nice even negative 2. So you can see, using the graph, using the formula, they're both going to give you the same answer. Once you get good at just looking and counting boxes, I think this is much faster, but it is important to see the correlation between the two. All right, last one, example number 4, finding the slope of a line just using this formula. Now what we want to know, what we're going to use, is this formula that you definitely saw before. In Math 8, this is your slope-intercept formula. Let's write that down. Now the reason it's called that is because it will give you the slope, which is right here, the m, and it will give you the intercept, which is the b. All right, so if we can put an equation into this form where the y is by itself, y equals everything else, whatever coefficient is in front of x, whatever number is in front of x, that's actually the slope of that line. And then whatever's being added or subtracted out here is the y-intercept. And that tells you where this line is going to cross the y-axis. So if we go back up to this one right here, this line right here, the equation for it, it's going to say y equals, the slope was negative 2, so that means it's going to say negative 2x. And if you see where it's hitting at positive 2 on the y-axis, so plus 2. So this is the equation of that line. If you plugged in any of these points, the negative 1, 4, or 2, 0, or 2, negative 2, into the x and the y, this equation will come out equal on both sides. This is the equation of that line. So you can see the slope is the coefficient of x. So negative 2 was my slope. And the y-intercept, where it hits the y-axis, is positive 2. And we're going to go more into that as we go. But all we want to worry about right now is, can we manipulate this equation to get it in this form, just so we can find the slope? We're just worried about the slope right now. So if you notice this, we've got a bunch of numbers and terms that are on the same side as your y variable. And for us to be able to pull the slope, you can't just say the slope is 2 because it's attached to x. Okay, it has to be in this form. It will change as you manipulate it. Okay, so we need y by itself, and we know how to do that. So we're going to solve this equation for y. So we want to get this y completely by itself. The 2x is going to have to go away, and this minus 5 is going to have to go away. All right, last thing we always do is the division, the number that's attached to the y. So the first thing we want to do is get this 2x to the other side. So basically, how do I cancel it out? So it's a positive 2x. I'm going to minus 2x from both sides of this equation. And that's going to leave me a negative 5y. Now on this side, you can put 4 minus 2x, but since this equation is always kind of put into this form where the x is up front, I'm going to go ahead and just put that x up front. You're not wrong to put 4 minus 2x, but we might as well put the x up front because that's just the standard form of this equation. So since it's a minus 2x, that's a negative 2x. Since that's a positive 4, it's a plus 4. Another thing that you can kind of use as a shortcut or think about, yes, we're subtracting this on both sides, but basically this was a positive 2x. And if you want to get rid of it and put it on the other side, all that happens is the positive 2x becomes a negative 2x when you switch it to the other side of the equation. Positive 4 just stays there. Negative 5y just stays there. Positive 2x, when you move across that equal sign, becomes negative. Now, mathematically, what we did was we subtracted it on both sides to eliminate it, and then we subtracted it on this side. But technically, it's a positive. You move it across, it becomes a negative. Okay, we're almost done. This is almost in the perfect form. The only thing is this y is still not by itself. So to get rid of that, I need to divide by negative 5. So I need to divide this entire side by negative 5. Everything by negative 5. Now, you can write this as just one big fraction like we have earlier this year. But specific to this situation, we're going to split it up because we want this in this form. We don't want this as one big fraction. So this is going to cancel. Y is by itself. So this is now going to give me all the information I need. Notice that these are two negatives. That's going to create a positive. We're going to leave this as a fraction. And I'm going to put it right in front. So notice I left the x outside. Now you could put 2x over 5. It's not incorrect. But we want just a coefficient out front of the x because that's going to be our slope. So we already have our slope here. And now it says plus 4/5 with a negative. There's a positive, there's a negative. So that makes this a negative 4/5. For our situation, this is good enough because we can pull the slope right now. But just in general, as we move forward, we're not going to write plus negative 4/5. We know adding a negative is like subtracting. So the best way to write this, the simplest way to write this, instead of plus negative 4/5, you just write minus 4/5. So either one of these is fine. Now we got to answer the question. We've gotten them in the correct form. What is the slope? The slope is whatever the coefficient is to x, the m in this equation. So it's right here and that. So the slope is 2/5. And again, imagine what that would look like on a graph. It's positive, so it's going up from left to right. And every 2 boxes that it goes up vertically, every 2 it goes up, it's going to go over 5. Okay, so if you have an equation and it's not in this form, if you can manipulate that equation to get it into y equals form, the coefficient of the x is your slope.